Hey Geometry class, we are now in Chapter 8. This is our first section that we're going to be looking at. And in Section 8.1, the objective is to find angle measures in polygons. And we're going to be looking at interior angles and exterior angles. So let's go ahead and get started. Okay, in this first thing that I have us do, as I say, do now, for each polygon, draw all the diagonals from one vertex and then to the other, okay? So what I mean by draw the diagonals, like one diagonal would be from here to here. That was terrible. Let's try that again. From here to here. That's a little better. Okay, I would not draw another diagonal. I'm not going to draw intersecting diagonals. I just want to draw all diagonals from one vertex to the rest of the others. And there's only one diagonal in a square or a quadrilateral, something that's four-sided. So now take a look at how many triangles do we have in this shape. We have 1, 2. So number of triangles, I'm going to put 2. And the sum of the measures of the interior angles? Well, since we have two triangles inside our shape, and we know that triangles interior measures all add up to 180, we have 180 times 2 is what we have here. So the sum of measures of the interior angles on this one is going to be 2 times 180, which is 360 degrees. Now let's do this again on a pentagon. So from this to here, from the same vertex to the other vertex, we can't draw from here to here. That's just a straight line. That's one of the sides. So the triangles that we see here, the total that we see is 1, 2, 3. So number of triangles we see are 3. And how we're going to do this now is this has 180, this one has 180, this one has 180. So 180 times 3 gives us 540 degrees. And that is the total angle measurement that all the interior angles in a pentagon add up to. So 540. Same goes for a quadrilateral. Each one of these angles will add up to 360. Now let's keep on doing the same thing. This one has 3 diagonals, and so you have 1, 2, 3, 4 triangles inside your polygon. So 4 times 180, 720 degrees. And now the pattern keeps on going. Notice that we have 4, and then we've gone down to 2 triangles. 5, gone down to 3 triangles. 6, and have gone down to 4 triangles. We have 7 sides, so each time we are subtracting 2 from the number of sides we have. So in this one, we're going to have 5 triangles, which equals 900 degrees. And then 8 minus 2, which is 6. That gives us a total of 1080 degrees in this octagon. Okay, so let's look at the theorem of polygon interior angle theorem. So theorem 8.1 states it's our polygon interior angles theorem. The sum of the measures of the interior angles of a convex n-gon, n meaning the number of sides that we have, is n minus 2 times 180, what we just concluded on the previous slide. Okay, so what this means is measure 1, 2, 3, 4, 5, 6, and on up to how many ever sides we have. The number of sides is equal to the number of angles we have in a polygon, by the way. And this is equal to what we have previously said, n minus 2 times 180. So this is how we're going to find the sum of measures of interior angles of any convex polygon. So we are given in this example here that we have a 21 gone. And here we have 35 gone, 50 gone. So whenever it's, we don't have, we're not going to draw out a 21 gone and then draw all 19 diagonals that it has to figure out how many triangles we have inside our polygon. We're just going to use this polygon interior angles theorem to help us in figuring out the measures of the interior angles on the inside of our convex polygon. So 21 gone, how we figure out the interior angles, the sum of the measures of the interior angles is we follow the theorem. We have 21 sides, which is our n, subtract 2, multiply by 180 degrees, and then what we get is, you can plug that into your calculator, and you should get 3,420 degrees. Same goes with 35. Plug 35 in for n, subtract 2 from it, multiply it by 180, and we should get 5,940 degrees. For 50 gone, same thing. We are going to take 50 as our value for n, subtract 2, multiply by 180 degrees, and we get 8,640 degrees. And that is all there is to this interior angles theorem. Now, we're going to be using this interior angles theorem in some more things later on. So keep this one in mind on how you calculate the interior angles of a convex polygon. Okay, so on these problems, it says the sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by the number of sides. So what we are given is the interior angle measurement, the sum of the interior angle measurement. So in this formula that we have given been previously given in the theorem that we just looked at, n minus 2 times 180 degrees, that is equal to the sum of the interior angle measurements. So all of this is equal to the sum of our interior angles that we are given, which in this problem is 1,440 degrees. So solve for n. First, to solve for n, leave these parentheses alone. We have 180 on the outside. Divide both sides by 180. Okay, and then we end up with n minus 2 on this side. And on the other side, let's see, what do we get? We get 8. And then add 2 to both sides to get rid of this 2 on that side, and we end up with n equals 10. So the number of sides that this polygon has is 10. And that's how we figure it out. So let's look at this. Let's kind of shorten this method here. To get the number of sides of our polygon, we first divided by 180 and then added 2. So exactly opposite of what we did to figure out the sum of the interior angle measurements. First we subtracted 2 and then multiply by 180. So do it backwards. Divide by 180, add 2. So on this one, I'm going to divide by 180 degrees, add 2. And to get my sum, well, not sum, but to classify the polygon, this will be how I get it. So this number of sides for this polygon will be 19. Same goes with this one. I'm going to come down here with it. Number 6. Divide by 180 first, and then add 2. And when I do that, I end up with 23. So this one's at 23 gone, 19 gone, and this one, if we're classifying it correctly, this one is a decagon. This chapter, you will need to remember your classifications of polygons from when we studied those. Those will come in handy in this chapter too, if you remember those, for this purpose of classifying the polygon by the number of sides. All right, on these two problems, it is asking us to find the value of x. X found here as one of our interior angle measurements on 16, we are going to need to first find what this total sum of angle measurements is equal to by counting the number of sides we have. I'm going to start here. 1, 2, 3, 4, 5, 6. We have a 6-sided polygon, or hexagon, we can call it, that is convex. And remember, use the interior angles theorem to help us in finding the total sum of the interior angles. So this right here. The number of sides we have is 6. Subtract 2, multiply by 180, we end up with 720. So all of these interior angle measurements should add up to 720 degrees. So let's take your calculator and add 88, 105, 142, 140, and 124 all together. And whenever you add all of that up together, you should get 599. And then we're going to add in that last angle measurement of x degrees. These angle measurements added together should equal 720 degrees. Subtract that 599 and we get x is equal to 121. And that is our angle measurement for that missing angle right there. Now let's do the same thing on 17. First step, remember, figure out how many sides we have. So 1, 2, 3, 4, 5. We have a pentagon here. So say 5 minus 2 times 180 degrees. That is equal to 540. Now add up all of your angles on the inside. I'm going to add the things that are like terms. So 3x, 2x, that gives me a 5x. And then 64 plus 86 and plus 110. All of that adds up to 260. And then that should be equal to the sum of the interior angles of a pentagon, which is 540. Now, what we do is solve our equation that we have. So subtract 260 from both sides, and then divide by 10, or sorry, divide by 5. We get x is equal to 56. We are done. Now, if we were asked to not just find x, but find the missing angle or find all the angle measurements inside our polygons that we are given, well, this one would have been easy. The angle measurements that's missing is 121. But these two, what we would have to do is take our x equals 56 and plug it in here, multiply it by 3, and for this one, multiply it by 2, and that would be our two missing angle measurements. Okay. Now there's another theorem, 8.2. It's the polygon exterior angles theorem. The sum of the measures of the exterior angles of a convex polygon, one at each vertex, is 360 degrees. And that is for any polygon. All of these exterior angles will always add up to 360 degrees. So, let's look at these examples down here. All of these angles right here should add up to 360 degrees. So, let's find what x is equal to. We have x plus 2x, so that's 3x. And then 93 plus 75, well, that is 168. And all of those angles added together are supposed to equal 360. Okay, now solve for x in order to find what x is equal to. So subtract 168, divide by 3, and you get that x is equal to 64. Now again, if I were to ask you what are the measure of all the exterior angles, and not just to find x, that's what the instructions were here, were to find x. You would plug in 64 into here. Well, one of your missing angles would be 64, but the other would be 64 times 2. All right, number 20 here. Let's look at it. Again, the sum of all these exterior angles will equal 360. But here we have 2x plus x plus 4x. That's 7x. Plus 90 plus 60 is 150. And then that is equal to, like I said, 360 degrees. Subtract 150 from both sides, and we get 210. And then divide both sides by 7, and we get 30 degrees. So there you go. We found our value of x. In these examples, it asks us to find the measure of an interior angle and an exterior angle of the indicated regular polygons. Okay, remember that a regular polygon has all side lengths are equal and all angle measurements are equal. So, to find the exterior or interior angle measurement, let's do that one first, of each of these polygons, the only thing you have to do is, I'm going to indicate this, interior angle of this one is equal to, well, heptagon. It has 7 sides. So calculate the sum total of the angle measurements that we have inside of a heptagon, which will be 7 minus 2 times 180. And then what we're going to do at this point is to get an anterior angle measurement. It is going to be, you're going to divide your sum total of your angle measurements by the number of sides that you have. So divide by 7, and you will end up getting 900 divided by 7. We're going to have to round here, so this does not turn out even. We get about 128.57 degrees. So each one of our interior angle measurements are about this many degrees. Now, after finding an interior angle of a regular heptagon or any polygon, the only thing we have to do from here to find the exterior angle is subtract our interior angle from 180 degrees. And that will get us our exterior angle that we are looking for. And I'll go back and show you why this makes sense. Okay, so an exterior angle, if we add up our exterior angle and our interior angle, it lies on the same line, which is a sum total of 180 degrees. So that's why I'm telling you, after you find your interior angle of what it is equal to, then subtract it from 180 and you have the exterior angle. Okay, let's do this one. Then I'm going to let you do 21 all on your own and see if you can do it by yourself. Okay, so an interior angle for a regular dodecagon. Dodecagon means it has 12 sides. I'm going to take 12, subtract 2, multiply by 180, and then divide by 12. So that is equal to 1800 divided by 12, which is equal to 150 degrees. And now to find the exterior angle of our interior angle, we just take 180, subtract 150, and we get 30 degrees. And we are done. And we're actually done with this whole lesson too. So hopefully that seemed short and sweet and easy. And I will see you all in class. And we'll do some exercises together. Goodbye, everybody.